Number 7, another little question, 2 marks. This has been fairly straightforward. Just find that. There it is. Well, you know the technique. If it was just x, it'd be add 1 to the power, divide by the power, 8 divide by 8. But if it's a function of a function, it'll just operate on that instead. So up to 8 divide by 8. But if there's an inner derivative, and there is, the inner derivative is 3, also divide by that. And don't forget plus c. That's about it. So just tidy up that coefficient. That's 1 over 24 times 3x plus 2 power 8. Power 8 plus c. Well, it didn't take a lot for 2 marks. Number 8, just a wee 2-mark question. You've got a 3-dimensional vector diagram. You've just defined a particular line segment in terms of these base vectors, knowing particular pathways along that shape. So how can you get from B to E using paths that you know? Well, you can go from B to A, because that's related to DC, A to D, because you're given it, and D to E. So that'd be the route. Go from B to A, and then go from A to D, and then go from D to E. Whoops. And put these circles around those to show vector addition if you like. Then, what are they then? Now, B to A, maybe I should specify this, is actually the same as the DC one, but backwards. So it's negative DC plus AD plus DE. Now I'm just going to add the vectors together. Now it's going to be a pest writing them out in that form there. I think I'll just put them down in a component form and then rewrite them in terms of the base vectors for the final answer. So DC, what is it? I want the negative of it though, so it'll be negative 2, 4, negative 2. Negative 2, 4, negative 2. AD is 6, 4, 2. 6, 4, 2. DE is negative 4, negative 3, 4. Negative 4, negative 3, 4. Then I'm going to add them up. That comes to 0. That's 8 take away 3 is 5. They knock out. That leaves me 4. But you have to express them in terms of, that's what it said, wasn't it? I, j, and k in terms of the base vectors. So I've got no i's. I've only got 5 lots of j and 4 lots of k. Number 9 then, just a wee 3-mark question here, recurrence relations. The sequence generated by using this recurrence relation on each term to get the next term approaches a limit of 10. If that's the case, what is this factor that you've got? Well, if it approaches a limit of 10, you could use your b over 1 minus a, or you could just do it intuitive if you like. If it reaches a limit of 10, that means if you put in a 10, you get out of 10. That's why it's a limit. You're not going to go anywhere. Every time you put in 10, you get another 10 out. It's pointless to try it anymore. So m multiplying a 10 plus 4 has to give a 10 out. So I'm just going to do it this way, solve that. Right. So that means that 10m is going to equal, take the 4 across, and that'll give you 6. So m must be 6 upon 10. You could cancel it down in the spot, but I'll write it down first of all. So m must be 3/5. Or, if they want a decimal, suppose you could put 0.6, whichever you prefer. Part B, given that U1 is 19, what was U0 the first term in the sequence? Well, that just means your answer is 19. So whatever you put in, we call that U0, you multiply it by whichever of them you want, 0.6, add on 4, and you should get a 19 out as an answer. So another wee equation to solve. We'll just do it in one go. Take the 4 across and subtract is 15. So it'll be 15 divided by 0.6. which gives you a 25. Because you didn't really need to use your calculator there, but it was a calculator paper, so why not use it if it's sitting about? Because you've got 3 over 5, that goes 5, and the 5 underneath makes it 25. But anyway, so that was question 9.